Okay, let's look at the programming wise by using the software for MicroC, and you are going to write a code, and then you're going to transfer it to the simulator, which are going to use the Proteus software. So this is the first interface for your MicroC. So I'm going to do a very basics programming, and we're going to do it on the simulator later. Okay, the first one, when you open up your MicroC, you will have this interface. Then you're going to have your first new project, which is you're going to start a project here, and then you're going to go for new project here. Okay, welcome to the new project wizard. So you just go for next. This is going to create the whole project. Then you're going to select the device and then set up the device clock, which is your clock 20 megahertz, and then add project files. This is not related because we're not going to add anything. So we're going to continue on the process. So next, first one, you need to select the PIC that you want to use. Remember that the name is PIC 16F877A. So you can see that if you go for the drop down, there will be a lots of microcontroller over here. So this is the one. Then you go for next. The clock will be 20 megahertz. Okay, then we'll go for next. And then the project file name, this is where you want to save your project. So let's go for the example here. Just go for anywhere that you want to go. I will try to put somewhere here coding examples for today. So this is a coding example, new folder, right? Code test 1. Okay, I will go to this one, right? To this folder. Sorry, not this one. Code test 1. This is the one. So there's nothing here yet. So the file name, this is your file. This is your source file. You can name any name, but it's up to you to make it more recognizable, or you want to remember that you can just put something that related to your project. So for this one, I just put code, and the save type is a MicroC project MCPPI. This is a MicroC project. Okay, save file. So I'm going to save this one first. Then you're going to for the next one, add to file project. There's nothing to add anything in this project, so you're just going to proceed. Then you're going to select all the libraries, which is all by default, and then we're going to do for the next session. Then you have successfully created a new project. Click finish to save the changes and close the wizard. So finish. So you're going to have your first project here. So let's look at the directory where I saved just now, the code test 1 just now. Let me open up that one for you first. Okay, so the first file here is code test 1 just now, right? This file is going to be generated once you save it. So only 5 of them. At the moment, there's no hex file, so we're going to write down the hex, write down the code. Let's try. So this is the first one. So you have like a C++, you must have the main bracket, the main body. Okay, so you have the main bracket, and then you have the curly bracket over here. This is what they call it, curly bracket. Okay, every time you want to initialize your PIC, right, you should know that which part that you want to use. So in this example, I'm going to use only one part, which is port B. Okay, let's look at the slides again. Okay, so where's port B? Okay, so not inside here for intro one. Okay, this is the port pin. So let's look at the port over here. I'm going to use the port B over here, and to initialize it, okay, to initialize it means that you have to set the ports, you must set it. So this is what we call port B area. This is all port B, and the registers that related to setup is the trace B, because this is port B. This is a register, and then another one, they call it the port register. So this is just a name. I just want to tell you guys this is a port B, but inside there's a RAM. Inside the RAM there's a port. There's a register called port, and this is port B must relate to this port B. So these two registers are different, and this is very important because you need to know that what you want to do with this port, because at this example I'm going to change all this setting for port B as the output. Okay, so you have to use trace B register and set it to make sure that this port B can be the output. Alright, so let's look at the example here. For example, if you want to set up as the output, you must put like this command: trace B is equivalent to 0B. This is to make sure that I'm using binary numbers 0, 0, 0, 0, 0, 0, 0, 0. This is binary numbers. So 8-bit. Remember that the register's size is 8-bit. So you can count from here. This is 0. Let me change this one. This is 0, 1, 2, 3, 4, 5, 6, 7. This is the size. So this is related to the pins for port B. For example, this one is RB0. So this one is related to this one. RB1 is related to this one. RB2 is related to this one, and so on. Okay, what does it mean now? If you put 0, you set up this one as 0, you are actually setting up the port B RB0 as the output. 0 means output. If you change this one to 1, for example, you change this one to 1. Okay, 1 means you are setting up the pin for RB0 as the input. So I don't want to touch the input first. Let's try to look at the output here. So I'm going to change back to this value to 0. Change this value back to 0. And then we're going to look at the command where you can use in the MicroC programming. So I'm going to use trace B is equivalent to 0B 0, 0, 0, 0, 0, 0, 0, 0. Then you have the semicolon. This is normally used when you use the C++ language programming. Then you are going to have another one. This is while one loop. While one loop. This is a loop. Then you're going to do something. So you have the void main here. Okay, this is the one, right? This is the one here. This is the closing here. And then you have the while one here in this bracket. So this is setting up the command. And I'm going to give another command, which is to give a signal out, because I already set up the pins to output. So from these pins, right? From these pins, I'm going to send up the signal of 5 volt all the time. So it means that I'm going to send up all this one to all 5 volt. So how to give a signal 5 volt? You are going to play with the port B registers. So right now the command will be port B is equivalent to 0B again, 1, 1, 1, 1, and 0, 0, 0, 0. So what does it mean here? So 1, 1, 1, 1 is going to give a 5 volt signals to 4 pins, and the other 4 pins remainder from 0, 1, 2, 3 is going to receive 0 volt. Sorry, this means that the first four here will have a 0 volt, and the other 4 we have 5 volt here. So that's the difference. So remember that your PIC can only generate a 5 volt signal up to that level, because the input is also 5 volt. Then of course the output from the pins that we have here is only 5 volt. Alright, so this is the one. So let's compile it. Do you have problem or not? Let's look at this. You can see that now this is the whole program, right? You're setting up the port B as the output, and then you are giving the signals 5 volt out for the 4 pins and another 4 pins as 0 volt. So this is by using this registers port, because port C is related to port C, and then this is to make sure that you do not confuse that when I'm talking about the registers. So let's compile this one. Build all projects, and then you must look at this particular compilation process. You can see that it's only blue in color. Then look back in your directory just now where you have the program just now. Let's open up that one. Just for all good examples. Good test. So right now, just now, before we run that one, right, you can see that the timestamp here is changing, and we have lots of file already in this C++, and then you have the hex file over here. This is the file that you need to do the you need to download to the simulator, or in the real world you need to flash or program on your microcontroller to make it run. Okay, so that's the first one. Let's try to use the command just now to your Proteus. So open up your Proteus. What you need to use is your this one, the ICs, right? So I'm going to remove everything first, delete. When you have these ICs, right, this is the first interface of ICs. Then you need to put your PIC. Go to this one, component mode. Go to this one, P. This one. And then you're going to use you're going to type the PIC 16F877A. This one. Double click this one, then OK. Then you can take this one out here. So in this simulator, it's already segregate all the ports. It's not the same one as the real world pin like this. It's not the same. You can see that this is a bit different. You can see that port C is over here, port B is over here, but this one is all put together. Means that you can see the pins number is kind of mixed up here. This is clear. This is your reset button here, right? So this is all the ports are being segregated and grouped together. So make your life easier in simulator. So right now, you're going to just try to turn on the LED by having the command just now, by giving 5 volt here and 0 volt over there. Let's try to run another one. Take out the LEDs here, LEDs. Do we have any LED here? Yes, this is the one. LED, just stick LED yellow. It's much easier for me to look at. So then you have the resistor, resistor. Okay, this is the resistor. So in real world, you must put resistors out. So the top 4 is going to receive the LED. Okay, this one. Then you have to use ground. Ground is this one, terminal modes, ground. this one. Let's try to link all the components here. Okay, then I'm expecting this one to be turned on. I'm expecting, hopefully there's no problem. So you can download the program from the directory just now here, not this one. Coding example, code test 1. This is the one just now. This is timestamp that when we generate this hex file. Today is 4:13. So double check this one, double click, and the clock is 20 megahertz. Remember that it's 20 megahertz. And then you can say okay. Alright, then we can try to turn on. So right now the power is there, but there's no lights because this resistor is very high, if I'm not mistaken. Let's try to change this value. Only 200 only. Then you can try it again. Then you can see that your LED is turning on. Why? Just now when you have your program written on the MicroC, right? Let's look at this one as well. Okay, and what happened here? And then you can see here, okay, the trace B is the one that's setting up what is the function of port B. In this program, I put all 0, 0, 0, 0, 0, 0, means that all these pins are going to work as the output, means that it's going to generate a signal out from it, going out. And then another command is, this command is to change the register at port B. So the command is 11110000. You can see here that when you have 1, the color will be red, which means that when you have a 2, when you measure by using the multimeter, right? So this is going to give you a 5 volt signals. Whereas the other 4 now is all blue. Is all blue is actually is giving out a 0 volt value. So let's try to change again this one. I'm going to stop the Proteus over here. Stop this one. Alright, no problem. And go back to your MicroC. Let's change this one to different case 10101010. Okay, and then you compile again. Build all projects. Okay, let's wait for this one. Alright, so by default I'm using the same folder over here. You can see that it should update to 420. So this is the updated version. So open this one. So this is the one. Then okay, and then we can run again. Look at the results here. So now you can see from the output of the blue and red color is different because I did set up as the 10101010. So this command is to give a signal out because I already set up this port as output, and then this is going to give 10101010. So let's look at the example. If I change the command, trace command here, alright, to all ones, which means that I set up all of them as input. Okay, is it going to work or not? Look at here again, run again, compile. After you change anything, you have to compile, which is to build all projects. Wait for the compilation completed. Okay, now finish, right? You can go back to your Proteus and then run again this one. Now you can see there's nothing out because this is not connected, right? Even though that's not connected, but there's a gray color. Actually, the system now, port B now is receiving, is actually an input. It must receive something out. Now it's received 0 volt from here because there's nothing here, means that it's received 0 volt from here, it's connected. So even though you are putting the port B out, right, this is actually the program is telling you guys to give the signal 1010 5 volt 0 volt 5 volt 0 volt, right? It does not happen because the thrice B syntax, the thrice B, this is the register name thrice B, have been changed to all one, which means that all the port B is set up as the input, so it's different. Okay, so that's the case for this one. So what you need to understand here is the method how to write a program. This is very basic program because you need to know what is to set up, how to set up, and how to use these two main very important registers. And then what you are going to look at the simulator over here. What's the result here? Blue color means what, gray color means what. So this is the example just now, how we should write a very basic program. Okay, so that's for the basic one. Thank you.